Hope so that you all are doing very well. So we are starting our prime factor decomposition and HCF and LCM. As the HCF, LCM for prime factors, the integers, these are the chapters from the everyday maths, and these in your P1 or P2 of mathematics 4024. So this is one of the chapter where you're just required to just understand the concept carefully. Okay, so we are starting within the prime factors. So what are the prime factors? Okay, this is also very clear to you in your previous classes. Yes, as nothing is new. Factors are things that are multiplied together. Prime numbers are numbers which have exactly two factors, themselves and one, such as number 2. 2 is a prime number. This is because that 2 comes in its own it's in own table and in the table of 1, but does not come in the other table. For suppose number 6. Can I say that 6 is a prime number? No. Why? Because 6 comes in the table of 2 and 3, such as 2 threes are 6 and 3 twos are 6. It means that 6 is a number not coming in its timetable and in the table of 1, but also comes in the table of 2 and 3. So it is not a prime number. Alright. The prime factors are of a number are therefore all the prime numbers which multiply to give that number. Alright. It means that if the prime factor are the numbers. Okay. For suppose I can say that there are therefore all the prime numbers which multiply to give that number. Okay. Prime factors are basically the number which is for suppose when you multiply 2 multiplied by 2 you get 4. Okay, if you I say that 2 multiplied by 3 you get 6. Okay, as you multiplying 2 by 3 or 2 by 2 means you're multiplying prime number with a prime number to give a prime factor. All right, you should remember the first few prime numbers such as 2, 3, 5, 7, 11, 13, 17, and 19. What are these numbers? These numbers are the numbers which only came in its own table and in the table of 1. Means themselves and in the table of 1. Okay. How do I find the prime factors? Okay. Use a factor tree to find prime factors. Split a number up into a pair of factors which multiply to give the number. Continue splitting up numbers until you get to a prime number. These cannot be split into anything other than one in themselves. Okay. A number can be uniquely written as a product of prime factors, such as write the prime factors in ascending orders with multiply between. Means multiply is simple the sign in the between each number. Okay. Now you are required to just see this example as prime factor is equals to, uh, okay, this 72 is equals to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. What are these? I'm saying multiply by and multiply. These are the prime factors of 72. All right, or you can in the power if they are be required to write it. Okay, so you can write just 2 per power 3 multiplied by 3 per power 2, as there are 3 times 2 written and 2 times 3 written, so you can just take a simple answer as 72. So what are the prime factors of 72? The 2 and number 3. Okay, how might a question be worded? These are the basic terminologies or the wording of the examiners which ask from you about the prime factor, as they can ask from you express a number as a product of prime factors, find the prime factor decomposition of, find the prime factorization of. These all means that they are asking from you about the prime factors. All right. Uses of prime factor decomposition. When a number has been written as in its prime factor decomposition, PFD, it can be used to find out if that number is a square or a cube number, or to find the square root of that number without using a calculator. How can I use prime factor decomposition to tell if a number is a square or a cube number? If all the indices in the prime factor decomposition of a number are even, then that number is a square. What are the indices? We have already discussed in the All right, so there was an internet issue, so I apologize for that. And we are moving towards how can I use the prime factor decomposition to tell a number if it is a square or a cube number. Okay, so we were at this. If all the indices in the prime factor decomposition of a number are even, then that number is a square number. For example, the prime factor decomposition of 7056 is 2 per power 4 multiplied by 3 per power 2 multiplied by 7 per power 2. So it must be a square number. All right. If all the indices in the prime factor decomposition of a number multiples are multiples of 3, then that number is a cube number. Alright? For example, the prime factor decomposition of 1728000 is 9 per power 2 per power 9 multiplied by 3 per power 3 multiplied by 5 per power 3. So it must be a cube number. Okay, how can I use to find prime factor decomposition to find the square root of a square number? Write the number in its prime factor decomposition. All the indices should be even if it is a square number. Half all the indices, this is the prime factor decomposition of the square root of the number. If you need to write the square root as an integer, then multiply the prime factors together. Now here are some steps for you. How can I use prime factor decomposition to find the exact square root of a number? Here you are required to just recognize the steps as step number 1, write the prime factors out as individual factors. Step 2, pair the factors together so that any two prime factors that are same can be written just once as a power of 2. Step 3, find the product of each of these paired factors ignoring that each one is squared. This number will be written as an integer in front of the square root sign. Step 4, multiply the remaining factors together. None of your remaining factors should be the same. This number will go uh, inside the square root symbol. Step 5, write the answer as a product of the integer from step 3 and square root of the integer from step 4. For example, the prime factor decomposition of 360 is 3 multiplied by 3 per power 2 multiplied by 5. As you can also write this as 2 per power 2 multiplied by 2 multiplied by 3 per power 2 multiplied by 5. Okay, so the exact square root of 360 is 2 per power 3, and then you're taking, as you can see that 2 and 5, 2 multiplied by 5 have no power on it, so we are taking the square root on them, and from out of the square root 2 multiplied by 3 is equals to 6, and in the square root 2 multiplied by 5 is equals to 10. All right, moving towards common factor, HCF. What is the highest common factor of two numbers? A common factor of two numbers is a number that both numbers can be divided by. One is a common factor of any two numbers. To find common factors, you can write out the factors of each number and identify the numbers that appear in both lists. Factors of a common factor of two numbers will also be common factor 6, 24, and 30. What does it means? That 24 and 30 comes in the table of 6. It means that they are the uh, it means that 6 is the common factor of 24 and 30. Therefore 1, 2, 3, 6 are also common factors of 24 and 30. As simple as usual, you can 2 11s are 24, okay, 3 10s are 30, 6 5s are 30. All right, the highest common factor is the largest common factor between the two numbers. Okay, this is useful when simplifying factors and factorizing expressions. How do I find the highest common factor of two numbers? Write each number as a product of its prime factor. Find the prime factors that are common to both numbers. Be careful with how many times a prime factor appears, as 12 is equals to 2 multiplied by 2 multiplied by 3 and 10 is equals to 2 multiplied by 5. So only one of the twos is a common factor. Multiply the common prime factor together using a Venn diagram can help. Put the common prime factors in the center. Put the other prime factors in the relevant circles. Okay, and HCL or HCF is the product of all number in the center. Okay, so we're just making the Venn diagrams in the set notation in the Venn diagrams. Least or lowest common factor, LCM. What is the lowest common multiple? Okay, sorry, it's least or lowest common multiple, LCM. What is the lowest common multiple, LCM, of the two numbers? A common multiple of two number is a number that appears both of their times table. The product of the two numbers is always a common multiple. To find common multiples, you can write out the multiples of each number and identify the numbers that appear in both lists. The multiples of a common multiple of two numbers will also be the common multiple. 60 is a common multiple of 12 and 10. It means that common multiple, it means that 60 comes in the table of 12 and in 10. Okay, therefore 60, 120, 180, 240, etc. are are also common multiples of 12 and 8. Sorry, 12 and 10. The lowest multiple is the smallest common multiple between the two numbers. This is useful when adding or subtractions. Okay, how do I find the common multiple of two numbers? Write each number as a product of its prime factor. Find the prime factors of the first number that are not the prime factors of the second number. Be careful with how many times as a factor appears, as 12 is equals to 2 multiplied by 2 multiplied by 3, or 10 is equals to 2 multiplied by 5. So 3 and 1, one of the twos are not prime factor of the 10. All right. Equivalently, okay, 5 is not a prime factor of 12. Multiply the first number by these extra prime factors. Either multiply 10 by 3 or and 2, or multiply 12 by 5. Both ways will give you the same answer. Using a Venn diagram can help. Put the common prime factors in the center. Put the other prime factors in the relevant circles. The LCM is the product of all the numbers in the Venn diagram. We'll be just solving the Venn diagrams in the set notation in Venn diagrams to just understand. Until that, it's here in the video. Finally, so this was the prime factors, LCM and HCF, which appears in your paper 1 and paper 2. Paper 2, whenever it's appearing in your paper 2, so you must need a calculator for it. And it's not even though tricky, but you're just required to just use the calculator for understanding the concept. I hope so that you understand the concept. If it still is remaining, so just comment me below. All right, and wait for the reply. Till that, take care.